In this question, we're dealing with exponential growth of a population. It says the population of a city was 226,000 in 1985, and the growth rate is 5.5% per year. So now what we're asked to do is find a function, find basically an equation, or a formula, if you will, that models or predicts the population after t years. So t is going to be our variable here. And it says around our answer to the nearest thousandth. Okay, well, we need to understand what the model is that we're going to use here. And we have to remember that the population growth model is here. Okay, this is the total population after a given time, nt, equals no, and this is the first number here, the one that's before the number e, is our initial size. So if we look back at our question here, our initial size here would be 226,000, so that's where we're going to plug it in right here. The number e times the rate, or number e raised to the rate times time, okay, the growth rate and the time. So now I'm going to take this equation right here and kind of move it into the problem that we've got here. So here's our problem, and n of t is going to be what the population will eventually be after a given number of years. But let's start plugging in stuff that we know. We know what our NO is. That's our initial size of the population. In this case, it was 226,000. So let's go ahead and plug that in now. That's the only thing I've plugged in so far. Now what we know is we know what the growth rate is. The growth rate is 5.5%. Now we have to, when we plug that into a formula like this, we're not plugging it in as a percent. We have to convert that to a decimal. And a decimal, if you remember, will move it over 2 spaces to the left, which will basically be 0.055. So we'll plug that in now. And now you look at this. This is the model. This is your formula, if you will, that we'll use for this. This will predict what the growth of that city will be. And we did that just by plugging in what we know so far. Now, the next step of the process, they ask us to use this model to predict the population in the year 1991. So here is our model. And we've got to determine, okay, 1991, let's see, that is t years after 1985. So that's the part that we know now. We know that that is 6 years after 1985. We just subtracted 1991 minus 1985, and that would be 6 years. So now what we're going to do is we're going to plug in 6 for t. We're going to use this formula that we just came up with, and we're going to plug the 6 in for t. There we go. So now that we've got that, now we can use that and plug that into our calculator right now. So let's take out our calculator. And I'm going to plug in just as it appears right here. I'm going to go 226,000. Second E. And this is the one, the number E is found right here above the LN button. It's in blue, meaning we have to hit the second button first. Then we can hit LN, and that's where our E does. When it does that, it automatically goes to the exponent, which is good. We're going to type it in just as we see it here, 0.055 times 6. Okay? And I'm just going to hit enter, and we'll see what it gives us as an answer. It gives us 314,358.8. So I'm going to, you're not going to round that one until we're ready for it. Now, this is our population, and so I'm going to just copy that over here. And this is good right now. You'll notice that I did not round up on this one. This is people, and so we can't have 0.8 people. So I just kept it. Kept it lower there. I know that the next thing is going to be asking us to round it to the nearest 10,000. Anyway, so the nearest 10,000 in this case is going to be 310,000. So we're rounding it now. Our answer would be 310,000. Okay, now we're going to continue on with this same problem here. We're going to continue to use this same function that we did, this model, this formula that we did for this one. And now it's going to have a new question. In what year did the population reach 450,000? So now we've got this information here, but we don't know the time. That's what we're going to solve for. What we do know is the ending population, 450,000. So I'm going to plug that in for n of t right here. So I'm just going to substitute that in. 450,000, that's all I did. And now what I'm going to do is solve this one for t. Well, if I'm going to solve this one for t, I've got to get everything else on the other side. So the first thing that I'm going to do is get rid of that 226,000. I'm going to divide both sides by 226,000. Okay, and for that you just plug it right into your calculator, 450,000 divided by 226,000. You'll end up with a number of 1.9911. Okay, and it does ask me to round it to the nearest year, but I highly recommend that you don't round it until the very, very end. Okay, so right now I've got this one, and I've got the number e, and this is still in my exponent. I'm trying to get this out of my exponent. The way that I'll do that is if I take the natural log of both sides. The reason why I'm taking the natural log is because my base is e, so that'll get rid of my e for me. So I take the natural log of both sides, and remember with our rules of equations, as long as we do it to both sides, we have not changed its value at all. So these two are equivalent values. I'm just adding this ln, this natural log here, so I can get rid of this e and get that out from the exponent here. And if you remember, part of our rules of logarithms state that the natural log already has a base e. So this is the natural log or log base e to the e. Okay, so those two will basically cancel each other out. So what we're left with on the right hand side here is just 0.055t. And that makes it a lot easier to try to solve it. So these right here just cancel each other out. Now the next step that we're going to do here is we're going to plug this left-hand side into the calculator. So I take out my calculator here. We're going to simplify this. Let me clear out what we've got in there. And I go natural log of 1.991. So natural log is right here. That's my ln button. So I click on ln and I just type it in. 1.991. I close my parenthesis. And then I just hit enter, and this will simplify it, and I get this decimal here. And again, I recommend that you do not round this until the very, very end. Go as far as you can, at least 4 decimals. 4 decimals seems to be a nice one that doesn't give you the wrong answer. So here's what I've got now. I plugged that left-hand side into my calculator, and it's simplified to this. Now it's just a one-step equation. I just need to get t all by itself. I've got to get rid of this 0.055. The way that I do that, this is 0.055 times t, so the opposite of multiplication is going to be division. I divide both sides by that 0.055. And again, we can do that with our calculator. And let me show you what you'll do here. I already have this answer entered in here, so I can just hit divided by 0.055. Notice how it says answer, ANS. That says that we take the previous answer here and we divide it by 0.055. And then I just hit enter, and I get this 12.52. And there's my 12.52. Now on this particular problem, it asked us to round, and let's see here, it says round to the nearest year. Okay, so this is 12.52. If I'm going to round that one to the nearest year, that will round up, so that's going to be a 13. But your answer is not 13. We have to remember what the initial year was on this particular one. So if we go back to the original problem here, the original problem said 1985, okay? So now that we know that it's 1985, we take that information, we go back to our 13 here, and we're going to add that to 1985. That says 13 years after 1985. 13 years after 1985 is 1998. So our answer in this case is 1998. And I know this was a fairly long video, but it covers several questions, and this will be key pieces that you'll need to know.